one of these giant star-forming regions, it's likely that they found themselves deep down inside the core of the star. And this time, the hydrogen atoms were converted to helium, the helium to carbon to oxygen, all the way up to silicon, up to iron. And then when it exploded, it made the gold that's in your jewelry. And that gold was spread back out into space in that titanic explosion at the end of the life of the star. After that gas spread out into space, your atoms found themselves in one final star-forming region, like the Eagle Nebula down in Sagittarius, the famous one with these beautiful pillars of dust sticking up. And this is really neat to astronomers because we actually see little clumps of gas up here, and those little clumps of gas are forming stars. And when we look at those forming stars, this particular group of stars comes out of the Orion Nebula, we see the stars, and we see surrounding them these black disks of dust. Those are planets in the process of forming. The last time you were in one of these star-forming regions, your atoms were not in the star. They were in that disk of dust surrounding the star. And as gravity clumped those pieces of dust together, they made little rocks. Those rocks clumped together to make asteroids. Those asteroids clumped together to make planets. And the fourth time that your atoms were in a star-forming region, they ended up not in the star, but in the third planet from the sun. And they weren't deep down inside the Earth. They were actually up close to the surface. Your atoms have spent most of their time up close to the surface of the Earth here. And that is where your atoms have come from. You are, as Carl Sagan said, literally made of star stuff. The atoms in your body were forged in the furnaces of stars billions of years ago. But your atoms haven't been in just one star. You've probably been in at least 2 or 3 different stars in the history of the universe. As I said, this time, your atoms ended up not in the star, but in the planet. The last thought I want you to leave you with is, what is the ultimate fate for your atoms? So you're made mostly of oxygen. What's going to happen to your atoms in the future? Because I hate to tell you, you don't own your atoms. You're just borrowing them for the time that you're here on Earth. Well, when we all pass away, whether we're cremated or buried, our atoms become part of the surface of the Earth. And over millions of years, those atoms will be recycled through plants, through animals, through other living things on the surface. Eventually, though, our sun will die. When our sun dies, it will become a red giant. And our star will get so big, the diameter here is 2 astronomical units, which means the radius is 1 astronomical unit. An astronomical unit is the distance from the Earth to the sun. Our sun will get so big that the outer layers of the sun will come all the way out to the Earth's orbit around the sun. When it does that, it may not be enough to completely vaporize the Earth, but it will vaporize the outer layers of the Earth. So your atoms, which are part of the outer layers of the Earth, will be vaporized off the surface. They will become part of the outer layers of this red giant star. And when it dies, our sun, you'll remember, the core shrinks down to make a white dwarf. The outer layers are blown into a beautiful planetary nebula. That is the fate of your atoms. You will someday be a planetary nebula. And I didn't mention it before, but I'll mention it now. See that green glow that's coming from the center of the nebula? Those are oxygen atoms. So those are the oxygen atoms that you are made of. And that's where you're headed someday, is you will be back out in space. And then after billions of years into the future, these atoms will be in the next generation of stars. So the Milky Way is like a giant recycler. Your atoms have been in stars, and they will be in future stars again, but you have them just for this short period of time. So thank you very much. I'm happy to take up questions for a few minutes. I think we have about 5 minutes for questions, so thank you.
Other questions?
Yes?
So does the city of Charlottesville have a black sky at any point in time? Is there no
No, Charlottesville does not have a dark sky ordinance, not a very good dark sky ordinance anyhow. I don't know that there's too much hope for getting it in Virginia. And I think really we're just going to have to work in rural areas and try very hard to preserve the dark skies that we have in rural areas today. But I'm not holding out much hope that there's any hope for taking cities like Charlottesville or Hampton and trying to reverse what we've already done. So, and we've worked, actually, I will say we've worked very hard in Charlottesville to try and get a dark sky ordinance, but there's just too much pushback from others. So, yes?
What is that grapefruit?
Yeah, so the middle of the Milky Way, the grapefruit in the middle, it's a big ball of stars called the galactic bulge. And those were some of the first stars to form when our galaxy was forming. And so if you look at it in that picture, it's just a big ball of stars sitting down there at the center of the galaxy. Really old stars. Yes? Down to it's a black hole. Its radius is just a couple kilometers, which is a couple miles across. So that is so infinitesimally small when we talk about distances that are this big that it has no effect at all. So, well, see, that's the thing. The black holes, they have this really bad reputation of sucking everything into them. And it turns out it's only if you get right up close to them that they suck everything in. But an interesting thing to think about our sun is the Earth is held in orbit by the mass of our sun. If we took our sun and shrunk it so small that it became a black hole, it turns out we haven't changed the mass of the sun. And we haven't changed the distance from the Earth to the sun. So even if our sun were to turn into a black hole, the Earth would continue to orbit the sun just like it does today. So it doesn't suck things in. The only way the black holes suck things in is if you get really, really close to them, close to what's called their event horizon, where gravity is very strong. But that event horizon is the thing that's just a couple miles across. So you have to get really close to black holes. Yes? So there are two things there. One is, do black holes strip matter off stars? But yes, stars are often born in binary systems, 2 stars orbiting around one another. And in those binary systems, if the more massive one dies and becomes a black hole, when the less massive one dies and becomes a red giant, that matter can get sucked into the black hole. There's a beautiful example of this in the constellation of Cygnus. It's the best candidate we have for a black hole. But isolated stars like our sun, which are not in binary systems, black holes are not at all common in the galaxy. It is not common. I would say, in fact, it's remarkably unusual for an isolated star like our sun to have an interaction with a black hole. And the only really massive black hole in our galaxy